Let's continue with these notes that we were doing. And so let's all type in this equation. So I want you to, for now, clear whatever you have in your equations, like all y's should be cleared. Some of you, I saw the plot ones were on still. They should not be highlighted. If you do, you will get error messages and you will not be able to solve the problem, right? So check that. We will use them later on. So let's type this in. So we go bracket negative 3 divided by 5 and then x minus 20. You cannot draw vertical lines, folks. You can only do diagonals and you can do horizontals, but you cannot do verticals. So x is equal to a number you will not be able to graph. I'll show you how to get around that. So we type that in, we hit graph, and it just happens to work perfectly for me. But how about we're all going to be on the same page here. So let's go zoom 6. You might not even see it, right? For all that, if you did your homework. Jasleen, right? Jasleen, could you turn off the front row for the lights there behind you? Just the front switch. There you go. There you go. Perfect. All right. So if you graphed it right now, if you go zoom standard, zoom 6, I'm not seeing anything. And that's exactly what I want to happen in this case, right? So we're going to go window, and we're going to extend our horizon. We're going to go negative 20. I'm going to go positive 20 on the x max, negative 20 on x and y min, positive 20 on y max. If you mix this up and the number for y min is bigger than the y max, it's going to complain. Right? It's not going to like it. So then hit graph, and we start to see a glimpse of it. We still need to do what? X min has to be decreased, right? So let's go, I'm going to go negative 50. I don't want to chase it, so I'm just going to go negative 50. And you see more than what you need, which is perfect. Out of precaution, I'm also going to decrease my y min a little bit. So I'm going to go negative 40. And so soon you'll be really good at this. You'll be quick at figuring out your window. I always like to go and see beyond just the bare minimum, okay? And so we've got that. And our window, I put these parameters down here, but let's just leave them. That's good enough, right? And so the second point was to graph it on the calculator. We've done that. Then we find the intercepts, right? Intercepts. We're going to find the X-intercept and the Y-intercept. You can do them side by side. To find the X-intercept, we have to use this method. Y2, it doesn't have to be Y2. It can just be any of the Y's, but you have to have a Y equals 0 line. And then you have to go second, trace 5, right, to find the intersection between those two lines. So let's go ahead and do that first. Y equals, if I have a bunch of equations that I want to see, I'm not going to do Y2, but in this case, I'm going to go Y2 is equal to 0, and it will be a red line. Hit graph, and there you see it. So it's basically the intersection between these two lines that is going to give you the X-intercept. So to find it, we go second, trace, and we use the fifth option, which is intersect. For now, it's all going to be either second trace 1 or second trace 5. That's all we're going to use in this unit, okay? And then you can scroll. It's saying, hey, you're on the first curve, and this is the blue, the first equation. You can go as close as you want to it, I'll tell you a secret, and I've told some of you already. If it's only 2 lines, you can close your eyes and just press enter 3 times. It will find it every time. Yeah, it will find it. Guess is always just, do you want me to start finding it? That's basically what it's saying. And you just hit enter. And if you're in computer science, it just does a loop. It just runs numbers through until it finds the intersection. So if you're a little bit further away from it, it's just going to take a little longer. That's all. Okay, so that's the intersection. So negative 33.330. So you write that down like that. And let's find the y-intercept. How do you find that again? It's second trace 1. And in this case, we know that the y-intercept is when x is equal to 0. Because you can type in any x value if you wanted to, but we want 0 in particular. Second trace 1, x is equal to 0. And it's right there. It's 0, negative 20, which is what we expected, but trust me, it's not always going to be that obvious. So you need to be able to do that. So listen carefully. When x is equal to 0, y is equal to negative 20. That is only for the blue line, right? What about the red line? If you go arrow up, it jumps to the next line on your cue, and that point right there is actually the origin, which is 0, 0. And if you had a third line, if you kept going arrow up, it would just cycle through all your y's, and it would give you what y is when x is equal to 0 for every single line. Does that make sense? Yeah, so arrow up is the way. Don't go side arrow, okay? Once you find the point, if you go sideways, you have to redo it because it will move it, okay? So 0, negative 20, you've got the intercepts. Good. And then the fourth point was basically when x is equal to 7, sorry, I'm going to erase that. When x is equal to 7, what is y? That's basically what they're asking you there. So because you're given an x value, you have to use second trace 1 and just let x equal to 7 in that case. So second trace 1, x is equal to 7, and it fits my window. If it's outside the window, it might complain, but you can actually see it coming up, right? So y is equal to negative 24.2. So what did you just find? You actually found a point. And so what is that point? It's the point 7, negative 24.2. Okay? That's basically what you found. It's just a different way to go about it. You were given the x, you found the y. Now you have the coordinate of that point there. And then the fifth option, find the x value when y is equal to 15. So they're basically saying, what's the x part of the coordinate when y is equal to 15? Which I made you do over and over on that worksheet, right? So for this, if you're given the y value, you're gonna go and say, I always say y2, but it doesn't have to be. But you're gonna graph a line y is equal to 15, and then you're gonna go second, trace, intersect, right? To do that. So let's grab our calculators, go to y equals, and I'm gonna just replace the 0 line with a 15 line. Is it gonna be on my screen? Nope, it's not on there. So what do I need to do? Window, right? X min is negative 50. Well, guess what? It's gonna have to be negative 70 or something like that. And there it is. Now I can go second trace 5, close your eyes and hit enter 3 times, right? Isn't that fun when you don't have to think, right? And so x is equal to negative 58.33, right? So what did you just find? You found the point negative 58.3315. And I want to add, we're going to find a point of intersection between A and B. So we're going to add that to our notes. And I'm going to reiterate the importance of doing your homework, right? To try, okay? So we're going to call this, I'm just going to say find the point of intersection between A and B, right? Those two lines that we just talked about. So what I will do is enter A into y1. So we're going to let that be 3x plus 15. And then enter B into y2. And that is negative 3 over 5x minus 20. So this is basically what I'm doing. And then second, trace intersect, which is really 5, right? And that's going to give me the point of intersection. Can you do this? Point of intersection, arrow to it, and just, I call it POI quite often because we want to save paper, right? So point of intersection, then you know. Sometimes they're called corner points, but they're all the same. They're referring to the same, okay? So I would like you to type that in, please. And really, it doesn't matter which order, so don't erase y1. We already have this one in, so let's not erase that. Let's just reverse the way we enter it. So I'm just gonna, your notes will never know. It's a secret between you and us, okay? There you go. So you type in both equations, that's important. One is going downwards and one is going up, right? Negative slope, positive slope, so keep that in mind. So let's hit graph. When we have them both entered, you can see the blue and the red. We see the intersection, easy as that. So we go second, trace 5, close your eyes and go enter, enter, enter. Right? When you see intersection down here, and then you're like, oh yeah, I got it. Oh, I pressed the arrow sideways. That's close enough. I'm just going to write that down. It's like, no, you got to do it again. Second trace 5, enter, enter, enter. And that's what you write down. So that's negative 9.72, round to 2 decimals, negative 14.17. Okay. We will graph them later when we do the worksheet. So I was going to get you to graph these, but we'll do enough of that so we don't have to go through it. One more feature that I will probably find, you will find it very helpful is if you press Y equals, let's say, right? And you don't want both lines to be displayed, but you want to keep it just in case you need it later. Go to the equal sign, hover over to the equal sign and just hit enter once it's deselected, it's not going to be graphed. So if I hit graph right now, it's only going to graph the blue line. And you will see where this comes in handy later on when you have like this maze of lines going everywhere. This might be a good way to do it, okay? So I'm going to clear everything now. Any questions before I move on? No questions? Okay. Let's do that worksheet. So I'm going to just